a remote controlled robot so that it can travel to different areas of the hospital healthcare center using input from the user. And then it could also securely and safely gather supplies and samples and then move them using user input to a different part of the healthcare setting or hospital. It uses two sensors, the IR sensor along with the IR remote, and then the ultrasonic distance sensor to detect if it's close to another object. And then it uses two types of actuators. It uses the DC motors to control the wheels and locomotion, and it uses the servo to open or close a drawer. Because I'm limited by the small breadboard and the number of pins for the demonstration, I've chosen to use two DC motors and a single microserver, but if I were to build out this robot to full scale, it would include 4 DC motors for the 4 wheels, along with 9 microservers for the 9 drawers. Before the demonstration, I would like to briefly go over the code. And the robot is controlled by 3 main functions. The first one is check dist for check distance, and this takes input from the trigger pin and echo pin to determine whether or not it is too close to another object using the ultrasonic distance sensor. There is move, which takes in 4 inputs, zeros or ones, and then applies those values to specific pins to determine the direction of the robot's locomotion or to stop the robot. Finally, there is use drawer, which is going to take 2 inputs, the state of a drawer and the drawer number, and depending on that drawer's state, it will either open or close the drawer. The logic of the code is broken down into 2 main parts. The first is going to check, hey, is there anything nearby? And if there is, I need to stop. The first comes from a warning that would be broadcast from a different robot, and that'll be printed on the serial monitor. And if I detect that message, the robot stops. Likewise, if the ultrasonic distance detects that we're within 6 inches of any objects, again, it will tell the robot to stop. The second part of the logic is going to control the IR remote, having an up, right, back, left, and stop button to control which direction the robot moves or to stop the robot, and then having the numbered buttons to control its corresponding or their corresponding drawers. And before the logic, I have initialized variables and pins located on the Arduino board. So for the demonstration, we're going to move the robot forward, backwards, left, and right, and then we're going to show the robot stopping if it's within 6 inches through the ultrasonic distance sensor, or if it receives a message from a different robot, and then we're going to open and close a drawer. So let's begin by starting the simulation, and then ensuring that we are not within 6 inches of an object. We're not. We're about 58 inches away from an object. And we can select the forward button, and in a moment we'll see both the motors rotating forward. So now the robot is moving forward. We can reverse the robot, and shortly we'll see the motors go in reverse. We can turn the robot to the left. We can turn the robot to the right. If we start both motors and then move us within 6 inches of an object, both motors will stop. Likewise, if we are further away than 6 inches, but on the serial monitor we receive a warning, once that message is received on the serial monitor, you will notice that a warning is printed and the motor stopped. Lastly, let's show the drawers opening with the help of the microserver. So if I select 1 for drawer 1, we'll see the microserver rotate to 90 degrees and the drawers then open. Or I can also select 1, because the drawer is open, it will now close. And likewise, if I select one of the other drawers, even though I don't have a microserver attached to it, we'll see in the serial monitor that it will say, okay, drawer 2 is now opening. And then we can click 2 again. And because the drawer 2 is opened, it will now closed. That completes the demonstration.